Friends, today's NRI Samay program from Los Angeles brought to you commercial free by listeners like you. Your generous donations make possible for us to stay commercial free, and today's show is pre-recorded. If you have a question for the guest, please send an email to nrisamay@gmail.com. We will follow up with the guest and find the answer for you. Thank you for your support.
The Prime Minister said last week, I have a vision. There shouldn't be a single family of the nation that doesn't have a house of their own by the year 2022. Great vision, but the numbers are mind-boggling, right? It would need 20 million in urban India and 45 million housing units in the rural India. And also it would mean creating an enabling framework for participatory action from public, private, community, and individual sectors. And by the time we achieve this in 8 years, which is 2022, India's population would be around 142 crores and counting. So we are adding at the rate of 2 crores each year, with more than 50% of all the new growth happening in cities. Good morning, friends. From Los Angeles, I am Srikanth Kocharlakota, and you're listening to the NRI Samay radio. Good to have you here on this Sunday, October the 19th. So for the next half an hour, I'll be in conversation with Professor Devdas Menon from IIT Madras. Professor Devdas Ji and research group at IIT Madras Civil Engineering Department has perfected the use of pre-fabricated panels made from waste generated by the fertilizer industry Gypsum. This is referred as green alternate technology as well, to erect the walls, lay floors, set up the staircases, all in about 30 days. The building doesn't even need plastering, uses much less cement, sand, and also water. In summary, the construction is rapid, cost-effective, and green. Devdas Ji is presently a professor in the Department of Civil Engineering at IIT Madras, engaged in teaching, research, and consultancy in structural engineering. You can get more information about Professor Ji on his website, devdasmenon.com, devdasmenon.com. And this is how I've reached to Professor as well, so please do reach out to the website. Professor Menon, thank you for accepting the NRI Samay request, sir, and welcome to the program, sir.
Okay, thank you. Go ahead.
Okay. So the technology that you're talking about will help construction of houses in very quick time. So climate change is a big problem, and it's been the discussion and conversation everywhere. We are seeing tsunamis, earthquakes, and floods. It has become a routine. We have seen the recent one in Jammu and Kashmir, Gujarat, Andhra Pradesh, and Assam and other eastern states, sir. So the technology that you're talking about can help in rehabilitation of victims, because you're saying that construction of houses can be done in very less time. So when you see these disasters, and as a professor of IIT who worked hard for a decade, what is the sense you get, sir?
Okay, now that's a different issue altogether. The work that we had done is largely to address the real housing shortage problem of India. And the houses that we propose to be constructed should be resistant to these natural hazards that you're talking about. There's a national building code which requires certain strength and safety measures. So we're not talking about rehabilitation of damaged buildings using this product.
Right.
The GFRC product is meant to resist any possible damage during its design lifetime. But that's a separate topic. If you wish, we can speak on rehabilitation. My thoughts are, a sense of real despair that we have not been able to solve this fundamental issue of providing good, simple engineering solutions to housing issues in our country. And this is largely because the entire construction scenario is largely unregulated in our country. I think you know that. And most of the constructions are so-called non-engineered. Some masonry building somewhere. And even in cities like Chennai, you would have noticed that recently a 13-story building just came down during the construction stage. So
right.
There are many reasons. Even in cities like metros like Chennai, there is no agency to check that they should satisfy fundamental stability and safety norms. The government is just not empowered to do that yet, and so there are a whole set of issues involved. But primarily, it's because the building industry is unregulated in our country. You can do anything anywhere. The numbers are very large.
Right.
So that's a problem with many dimensions, but mostly related to policy issues and implementation issues.
Absolutely, sir. Absolutely. So the technology you're dealing with is called GFRG, which is glass fiber reinforced gypsum. So what are the sources of this gypsum and glass? Is it really available to an extent that we can imagine to solve the housing industry, sir, housing problem that we are seeing?
No, that's a good question, but the demand for housing is mind-blowing in our country. I think the estimated number close to about 80 million houses we are short in both the urban and the rural sector. Traditional types of construction take a lot of time, use a lot of resources, and I think current government's plan is really to solve this housing problem. I think they've even given a date, 2022, and so on.
Yes.
But how do you do that? You need, first of all, you need to have that construction. So, certainly one of the options is you going for prefabricated solutions. It should be done very quickly and efficiently, but more important, it should be sustainable. So we can't keep going on using high energy intensive materials. Cement is highly energy intensive. Steel is likewise. Cement and sand and water are precious. Sand is not even available in many parts of our country. So we need to look for many options, and we believe that the technology that we are suggesting is one such option. Certainly, we are not suggesting that it will solve the housing problem, but it will certainly make a big contribution if we can scale it up. If there are factories that produce these panels all over the country, and if there are qualified agencies which can build up these houses. The good news about this kind of construction is you can't go wrong much if it's well implemented. The panels by themselves are very sturdy, and you have to just ensure that the connections are done well. And we believe that can be done. And so with proper training, this can be quickly implemented.
Right.
In fact, our director at IIT Madras has been asked to put up a note before the government of India, and we've done that. So we're waiting to see how this can take off.
Right.
Basically, it uses a waste product of the fertilizer industry. So wherever there's a fertilizer plant, and there are a lot of fertilizer subsidies also available, you can set up these plants.
Right.
You can also use natural gypsum.
Right.
And there are many ways of implementing this. One is, of course, the government itself comes in. The other is the private sector coming in. And the private sector has shown a lot of interest. And already in Cochin, there are 3-storied houses being built, mass housing, for the Kerala State Housing Board. Then Tata Housing is going to build, I think, starting next month, 5-story buildings at a place called Boisar near Mumbai. And so we hope that it will take off. Both government and private sectors will utilize this concept. But it's one among many options.
Right. Right. I've also heard about a builder in Karimnagar in Telangana area who was talking about, putting some sort of aluminum framework and putting concrete there and building houses in very less, it's also sort of rapid construction technology. So as you mentioned, there are many technologies out there, but let's focus on the technology that you're talking about, sir. So when you talk about these technologies, and that too homegrown IITs, which is fabulous educational institute, so do governments listen, sir? Because as you mentioned rightly, that, it should have a proper housing policy framework and removing various regulatory roadblocks, providing the fiscal incentives, support mechanisms. And these are all certain things that the government needs to do, because end of the day, you're saying that there is interest from the private sector, from the government sector, and from the governments. What sort of response do you get, sir?
Yes, I think we should look positively here. I'm trying to think along the lines of our former president, Abdul Salam. Whenever we, and especially when NRIs raise these issues about, look what's happening in our country, it's a mess, there's so much corruption, the policies are not being implemented. The reply that we would like to give is, yes, all that is true, but tell me something new.
Right.
Are you on the side of the problem or are you on the side of the solution? So I believe all of us should be moving towards the side of the solution. This is our country, and we all have to work together, fully cognizant of all the issues involved. And we have to do it in different ways. Now, you're right about IITs. See, we're being pulled in many directions. On the one hand, we're being asked to compete at the international level, publish papers in the best journals possible. But they all related to technologies that are not necessarily relevant to the needs of our country. You mentioned the poor people of our country. Our needs are very simple: roti, kapda, makan. And really speaking, IITs are not focusing too much at this end because of various other pressures of, ranking and competing with the world.
Right.
So some of us have chosen to also work on these lower end but very important needs of our country, and actually spent 10 years working on this kind of solution. But it's paid off in the sense that everybody is now working. This demo building we built inside IIT has been visited by many, many dignitaries, many ministers. And so they are all aware that you have a potential solution, and we've been encouraged. The government of India has, through the Department of Science and Technology, given us funding to really bring it to the stage of technology transfer. So I am very positive on this, and I know there are problems associated with actual implementation. So as far as low-cost housing or affordable mass housing project is concerned, not only the previous government, this government is also highly geared to take it forward. But the other issues that you mentioned need more long-term solutions about the basic lack of regulation of all construction in the country. So that's a real hard problem, and I wish all of us put our heads together and see how that can be implemented, because basically it's a question of integrity. We have to be technically sound in what we are doing, and we also have to be morally sound in what we are doing. So real estate, as you know, is not all that clean in our country. Land, property is involved, and then there are many middlemen, a lot of agencies to be made. Approvals have to be obtained. At every level there are integrity-related issues. And for that we need to really act at a larger level. But as far as IITs are concerned, our contribution there is a little limited. We can only contribute towards making sure the technology is first-class. Many of us are serving in the Bureau of Indian Standards, so we want to ensure that the right standards are maintained. And we can also help in contributing to policies, but actual implementation really needs also to lift our levels of consciousness and put our hearts and souls together and contribute to our country. So that's a much larger problem. But I will still like to look at everything positively and hoping that, we can still move ahead, not get dissuaded by the problems that we are facing here.
Absolutely, sir. I agree with that, sir. Sir, all these videos that is related to GFRG and the way IIT has built it in less than a month, and those videos. I have gone through all those videos, sir, and at the bottom of the videos, there are a bunch of people who say that, sir, I do have land here, sir, I do have land in Maharashtra, I do have land in Darjeeling. Sir, how is that you guys can help us out, construct a building? I want to construct a building at my place. Can you help? So what are these guys asking for, sir? Is it possible that private people who have already got land and who are looking for your technology, can you guys provide them this sort of support, sir?
Yeah. You see, that video has gone viral, and we are getting email requests, phone calls on a daily basis from people, not just in our country, but from NRI, from people abroad, from potential builders, from people who just want to build their house somewhere in some rural area. I think they are all genuine requests made, and we need to answer them. And we are actually attempting to do that. So first of all, we need a lot of people who can build this. So we ourselves, being professors here in IIT, we are not into real estate and actual building. We can only help. And so we are conducting workshops on a regular basis. We're trying to operate through the manufacturer. FRBL Cochin is moving very positively. So once every 6 months or so, we conduct these workshops for structural design and for construction. So we have a plan in mind where in the not too distant future, this will be available to everybody to build. How it can be built, we have shown on the video, but that's not enough. We need to actually scale up the numbers. There are private companies which have come up, which have specialized in this. To name a few, in Kerala, there are 2 or 3 which do only this type of construction. In Karnataka also, there are a couple of builders who do this. Now companies like Tata Housing are coming forward to do this. So anything new will take a little time to we can only broadly facilitate being an IIT. We can't really, give up our jobs here and go all over the country to build.
I agree, sir.
It's been built in the northeast as well, in Himachal, in Dehradun. Many of the new IITs want to build using this hostels and the faculty accommodation. There are 2 issues that need to be addressed. One is availability of this land. And for that, we first need to set up plants all over the country. We are working with many agencies on that. Second is to give a lot of training to facilitate good construction of this. So yes, that video was deliberately made so that people sit up and take notes. And everybody can sit in and go ahead and start building. Finally, I hope the day is not too far where you can actually buy these panels in any hardware shop, just like you buy, roof sheeting, cut to size, and pick it up and go and build your own house.
Wow.
So, but that's the future.
Yes, certainly. Okay. So training and also these workshops are very integral part of taking this mission forward. So when is the next workshop, sir, and where do you do the next workshops? Any insights to these people, to the listeners who are listening?
I believe that it has to go together, but training can wait a little bit, because let's say you train people, where do you have the panels to use them? Because all the panels right now being produced by Cochin are being fully utilized. So we have to work parallelly on the other side, and we hope that the builders whom we train will also go ahead and train other people. The plan that we have is the manufacturers like the FRBL at Cochin will themselves set up training centers. Not only that, we'll also start providing certification centers. And I think that we have to have clarity on how this can be done. There is the structure which needs to be done properly, and there are finishes which anybody can do, and which is part of any structure.
So when we talk about this technology, GFRG, glass fiber reinforced gypsum, What are the sources of gypsum and glass, sir? Is this really available to an extent we can imagine in this country, sir?
Yes, of course. First of all, for people in the US, you'll be already familiar with the gypsum board that you use in buildings there. It's very common. That gypsum is usually around 12 mm thick and used for partitions. It's really not a load-bearing material because it has two fundamental shortcomings. One is it's not strong to take loads, and the second is it is moisture absorbing. So two issues which have been resolved in the last 20 years thanks to an Australian technology. The calcination is improved. So it's becoming, what we have is actually two of those panels interconnected with ribs with cavities. So the panel is actually 124 mm thick. That's about 5 inches thick. Mm-hmm. And it can be filled with concrete. And what gives it strength is the glass fiber, which has tensile strength, fed randomly into the gypsum while it's being calcined and rolled. So we really have a good product which is using this waste material. Gypsum, the industrial waste gypsum from the fertilizer industry itself is quite high, around 40 million tons, rising up annually. It's just lying in heaps of white mounds. I think you can see some of those pictures in the videos.
Yes.
And they need to be disposed. It's a waste material. It's harmful. And so it needs to be... this is a fantastic use of that waste material. That's exactly what sustainable development is all about. But right. Of course, you can use natural gypsum to do that.
Right.
Now, both gypsum and glass fiber are easily available and can be used. So that's not an issue. There are companies which are actually looking to set up these plants all over the country. So they've looked into the availability issue. It's certainly a viable, feasible problem.
Wonderful. Sir, yeah. Sir, the other side of it is you mentioned... Go ahead, sir.
Yeah, incidentally, there are interests shown by many countries, West Asia, Africa, and so on. So it's not just India that's going to use this technology in a big way. The whole world, especially the developing country where housing is a big issue, and they are all planning to set up plants in their own local regions and go ahead with it.
Oh, wonderful.
Go ahead.
Yeah. Sir, the other question is that we certainly know that this technology originated from Australia, and it's been around 20 years it is there. But Australia doesn't have much of an earthquake, sir. So are there any durability issues with this? Would it suit the Indian climate well, sir?
Well, Australia has cyclones, so at least one disaster you should know about. They have heavy rains.
Right.
And actually, about 10 years back, when we visited Australia and saw this product, it struck us that, and it's not being much used there, and they call it rapid wall because they use it only for building walls. Mm-hmm. So it struck us that this has got many more uses, but they have to be tested out and researched upon, and that's how, when these plants were being put up, we were involved. We were also asked to prepare the design manual. So we've been working on this. So the first thing we were concerned about is earthquake resistance, because 2/3 of the Indian continent, subcontinent, is vulnerable to earthquakes.
Right.
It doesn't have those earthquakes. So we did also studies on that in our lab in Madras. We were also fortunate to see some testing done in China. We visited Beijing for the World Earthquake Engineering Conference. We made a visit to the Shandong Province, where in the Shandong University, they were also exploring the use of this for the Olympic village in France. Mm-hmm. And there we actually witnessed the actual load test, a 6-story building, with just walls made up of this, small rooms and so on. And it stood up very well, like we couldn't break it down even to the highest earthquake load.
Okay.
So the first thing was to see how to
actually designed this to take earthquake loads, which means you have to put reinforcement in the cavities, and we know now exactly what to do, in which cavities to fill, whether to put 1 bar or 2 bars in the diameter of the bar, which varies from 8 mm to maybe about 16 mm. So we've got design charts which can really make sure that the walls take the load. You see, the walls are all interconnected, so you've got nice boxes in your rooms, and that's really strong in earthquake resistance. The other innovation we did at IIT was to speed up construction. We knew very well that the same vertical panel, when flipped over horizontally, can very well serve as a slab if you can integrate it with concrete. Cut open, say, every third cavity, put a hidden beam there, which was never done in Australia. Now they're doing it in Australia as well. Actually, next month we are planning a visit there to see how they are using the work that we had ourselves done. So there are only these two materials being used in the construction. We use it also for staircases, balconies, and the demo building we built at IIT Madras actually demonstrates everything. So a lot of research has been done since the original discovery of or invention of this panel, which was rapid wall. Now it's rapid floor, it's rapid everything. So we built that 2-story building in IIT Madras with covering 2,000 square foot.
Right.
That construction was done in 1 month, and it's about a year and a half back.
Right, year and a half back. Yeah. Sir, and that video, I've seen it, and it's going viral as well, and there's a lot of enthusiasm on that front, definitely, sir. Sir, one other thing I have on that I have a question on the gypsum is not a stable product, and it absorbs a lot of water, right, sir? Would that be a problem, sir? How did you tweak the design to suit the native conditions, sir?
Gypsum is a stable product. The pyramids were built using gypsum, so what makes you say gypsum is not stable?
Oh, okay. Yeah.
This is a calcined gypsum, which is a different cup of tea. You should come and visit our house, and people ask us this question, what's the life of this structure? And honestly, we don't know. But we ask them to guess, because we built this as an extension of the guest house. The guest house we have here is called Taramani Guest House. This looks fabulous. And all of them on their own say, yes, this will last longer than the conventional construction. We hope so. We hope it will at least last 75 years. But it needs to be maintained, painted once in a while, and it will hold good. We don't see any problem. And lots of research has been done. It's being impacted by heavy rain. Australia faces heavy rain as much as Chennai today is facing. So we have this demo building being bounded by rain also. And let's see how it works. So we're fairly confident that this will last at least as much as conventional brick and mortar construction.
Right, sir. So when I hear about this technology, I've been hearing that this is very earthquake resistant, and also some people say that it is pest resistant, and also it is fire resistant, hurricane resistant. I'm hearing lots of different things about this. So recently,
you must be careful when you hear those things, because materials themselves per se are not resistant to anything. It's how you design them that makes them resistant.
Wonderful.
Any building potentially can be made resistant if you've designed it properly and constructed it properly. So that's the end result. The material by itself is not earthquake resistant. You have to see how many floors you're building, how the rooms are arranged, how you're going to infill the cavities with concrete, and what is the earthquake zone that you're building in. India has 4 earthquake zones, so the number of stories will come down in a very high earthquake zone. So it's basically how you do it. Even a normal building with bricks and stone can be made earthquake resistant if you know how to bond the bricks together, if you've taken care of the detailing. So I think we must clarify this common misunderstanding about materials being earthquake resistant. They are not. You need the human intelligence to make them earthquake resistant.
Right. Yeah. So also, when we talk about this new technology, and the new construction design, does it need to be approved, sir? Like it is not conventional type of construction, so does it need any set of approvals from others, or who approves it, sir?
Well, right now, in India, if you want to bring in any new material for construction like this, you have to get approval from the ministry, the urban or rural housing ministry, and they have set up a department called the BMTPC, the Building Materials Technology Promotion Council, and lots of tests and approvals have to be obtained before this can be officially used anywhere in the country. And that has already been done. All that approval is already obtained, and there's a government-approved design manual also for use of these buildings. And now a code, Bureau of Indian Standard Code is pending approval. So once all that comes out, those approvals will automatically come. But right now, the government has given sanction to build these up to 10 stories anywhere in the country.
All right, perfect. Sir, and also when we see these videos, it's all about panel manufacturing, and we understand that this panel manufacturing units are a very important part of this whole process. And the video shows the FACT Cochin Industrial Unit. Are there multiple industries around the country right now, sir, or how is it, sir?
No, right now, unfortunately, there are only two of them. One is at RCF, Rashtriya Chemical Fertilizers in Mumbai, which for various government bureaucracy issues is not manufacturing anymore. But they partnered, RCF partnered with FACT to create this new entity called FRPL, which is doing extremely good work. I suggest you contact the CEO of that organization. He is really forward-looking. His name is CP Dinesh, and the chairman of or managing director of FACT, Mr. Srivastava. They can give you lots of inputs on the manufacturing process. And the government is showing keen interest in putting up such plants wherever there is a fertilizer industry. So we are really looking forward to more numbers. It has two obvious advantages. One is, of course, easy availability with minimal transportation costs. The second is when you scale up, the production cost comes down. See, right now, these guys in Cochin are producing only in one shift. So if you run it 3 shifts, the cost per square meter of panel can come down drastically. There's a lot of wastage occurs when you start it and switch it off and start it again, the whole process. So they know that. So we hope that those problems will be surmounted.
Absolutely, sir. Sir, one quick question is Karnataka State Police Housing Corporation Limited. They use the GPS panels. Is it something that the technology was borrowed from the IIT, sir?
No, not that I know of. See, there are many options. They use this polyurethane foam and put a layer of concrete on both sides. I think SERC in Madras has also done some work on that. But those are all not scaling up in a big way. Basically, you need, it's like a Lego set. You need something that you can order and get very fast anywhere. And I think for that you need proper prefabrication. There is prefab concrete available, but that's not sustainable, and that's not a good thing to do because you're using high energy intensive materials.
Right.
This is, and there is of course the PEB industry, where you have cold form steel sections, Syntex and others are doing that. But you have problems of comfort. The product that we are suggesting will give you the same comfort levels as conventional houses, and will be much cooler and lighter. So other technologies are trying, and certainly there's room for all. So we can only promote the one that we've researched on for the last year.
Right. So you mentioned about these panels being a little cooler. So when I'm from a place called Vijayawada in Andhra Pradesh. It's very, very hot. So do you think anybody who's going for such houses will feel a little better than the existing technology for the concrete buildings that are being constructed?
one of our PhD students actually took some measurements, and we're going to publish those results in Taramani Guest House, which is, just inside the IIT campus. The IIT campus itself is a little cool compared to the rest of the city because we have a lot of trees here.
Right.
But a lot of measurements were done, and we see that in the summer months there's a 3-degree drop compared to the conventional house or a room of the same size. So that's proof if you want.
Oh, wonderful. Wonderful. So some of these questions that people asked...
One more issue is, of course, you need to also take care of ventilation. So there's a design, there's a human intelligence that comes in here. That's where you have to put in your brain power and see how best you can ventilate a house, how best you can bring in daylighting so that you functionally do the best that is possible and use nature in its best way. And that's what we used to do in the old traditional housing in India, isn't it? It was all naturally ventilated. We didn't have any fans and all that. Now so we want to cut down the use of power also if you have good ventilation.
Right. Absolutely, sir. Yes. Sir, you've constructed this building an year and a half back at IIT. It's still there. Do you feel that there are certain things that could have been better, sir? What do you think about? Did you get any inputs, or you felt for yourself that needs some change?
Of course. Yeah, we learn as we grow more and more, and we hope we'll implement all this in next month in Mumbai. Those 5 story blocks are going to be built by Tata Housing. So we know that certain improvements can be made, and we know that we keep learning as we move on. So, but they are of minor nature. The real thing works. For example, one area which we would like more research to be done is on waterproofing, because the solution should be really economical and should be guaranteed for maybe 10 years. Because many parts of our country have heavy rainfall, and we don't want leakage in the roof and so on. But that's a problem we face even in our regular houses. So those are areas that need further research and improvement. But as of now, you're welcome to visit this demo building. It's already occupied. Three flats have been given out. Our own faculty and their families are living there.
Wow.
One we've kept for to see. So it looks as good as new. And there are little issues. For example, in the roof, we tested by filling the roof with 7 inches of water, hoping that everything would be well. But we found that the parapet slab junction was a place where water would seep in, and one reason we found was because of the sheer hydrostatic pressure of that filled water tank. And it's not meant to be a water tank. So we've now discovered it's important to do a coving at the junction between the wall, the parapet and the slabs. And we saw that if you have a large room and the panel is only 3 meters wide, you have a joint there. And earlier we didn't do any treatment of the joint, we just left it there and just put the topping on top. But we saw that that's a possible place where you could have a possible parapet. So now we've come up with a simple solution of filling 6 inches on either side of every cavity, and that will close that. So we learn this way that, children first learn to crawl, and then they stand up, and then they walk, and then run, and maybe you can fly. So
absolutely, sir. Absolutely, sir. What a way to end this. And sir, thank you very much for doing this. I have a land in Bangalore, and I don't know, is it so easy to construct a house in the land that I have in Bangalore?
We have builders in Bangalore who can do it. I can put you in touch with them.
Oh, wonderful, wonderful. Sir, Devdas, sir, it's been a great pleasure, honor, and also deeply impressive conversation, sir. I'm so happy that at NRI Samay you've given your time, and then our listeners would get a sense of what sort of innovation is happening in terms of addressing the core issues that the country is facing right now. So thank you so much, sir.
Thank you.
Thank you.
Bye.
Thank you. Bye. So friends, that was Professor Devdas Menon, and Professor Devdas ji and his research group at IIT Madras has perfected the use of prefabricated panels made from waste generated by the fertilizer industry. It's called Gypsum. They also refer it as a green alternate technology. It's being used for erecting walls, laying floors, and also set up staircases. And all can be done in less than 30 days for a big building, which they have already set the parameters there in those videos that you go on YouTube. You can type GFRG.
Friends, if you liked today's show, please go to youtube.com/NRI Samay and click on the subscribe button. You will get notified every time we publish a new show. And you can also like us on our social media sites like Facebook, Twitter, and Google+.